Okay, so for this section, we're going to take a look at our other strategies for integration. These last ones, they're more kind of require some outside tools, right? Instead of some kind of technique that we develop, right? The first one is simply sometimes there is just no straightforward approach that can be done with parts or some kind of trigonometric substitution or trigonometric integral. And it does require some just advanced algebra and calculations. And in which case, what we can do is we can just really look it up essentially, right? Look it up using a table, right? Now, maybe in class you've seen me have this big laminated sheet and there's a bunch of stuff on there, right? I've used it to recall what a derivative is. And then also what's on there is just a list of integrals. All right, and if you look at the back of any calculus textbook, including ours, there is always a section where there is just a table of integrals, right? And that is also what is on that big laminated sheet. And I took it from pages from another calculus textbook, right? And here I'll switch over here, and this is from our own textbook. This is just the web-based version, right? And if you go on the table of contents, it's one of the appendices, right? Appendix A, the table of integrals, right? Also table of derivatives, right? Review of pre-calculus. And really these three appendices is what you see in that big sheet of mine that I carry around during class, right? And there you'll see a list of, right, basic integral stuff that we've done before, right? In probably Math 1, right? Our trig integrals, right? And my goal here is to evaluate this just by looking it up, really. Looking it up, it's essentially pattern matching, right? So I know it has a root, right? A difference here where the x is on the minus sign. And then there's extra x out here, right? So let's see if I can match something up here, right? So it's not a trig integral. It's not exponential. It's not hyperbolic. Just kind of scrolling down here. It's not an inverse trig. Now here we go, right? Integrals involving a squared plus u squared, where u is u is the variable of integration. So it's not this one. It's not u squared minus a squared, although it is close, right? Looking here, I want it the other way, right? A squared minus u squared, where in our case, u is our x. All right, here we go. A squared minus u squared. All right, now scrolling down, root, but I'm looking for a root in the denominator. All right, so 89 here. That one has a root in the denominator, but has a u squared on top. So it's not quite what I'm looking for. Here we go. All right, integral number 90 here. All right, so if we look at this one here, that's exactly what we have here, right? Du, right? U in the denominator and then square root of a squared minus u squared. So for my particular one, a is going to be 9. Right, and it's going to follow this pattern, right? Negative 1 over a. ln of a plus the root, exactly how it is, a squared minus u squared, all over u, all right? So here, for my particular case, a is 9, and u is just x, right? So what this is going to turn out to is 1/9, right? And then ln, absolute value was a plus the square root of a squared, which is 81 minus u squared x squared all over x. And of course, can't forget the plus c. Okay, and that's it, right? Just basic looking up an integral, right? Now, in some cases, when we do have an integral, it is going to require some preliminary work to do, right? So what I mean by that is, let's take a look here. Cosine x over sine squared x plus 2 sine x dx. Okay. All right. Now, initially, there's a lot going on in this integral. All right, I have cosines and sines, but not only that, I have a sine squared and then just a linear version of the sine, right? Sine of x. So here, I say, okay, well, let me do a u substitution first, right? Because even if I look at my table, and I clearly it's some kind of trig integral, but if I look at my trig integrals, there's nothing really there that is helpful, right? There's some power reduction ones, There's a mixture of sine and cosine, but that's not really what I have, right? I have a mixture of sine and cosine in numerator, denominator, and different powers of sine. So these aren't really helpful. So when I see that, I'm like, all right, well, maybe I need to do something different, right? And right away when I'm looking at this, right, what sticks out here is that the sine is where the sine is the function that has a lot going on, right? It's squared, and then there's just a 2 sine x. The cosine is almost there, like it's begging, like it's asking for a u substitution, right? And I want that u substitution to be sine of x, right? And now why this? Well, because when I do that, the top part, cosine x dx, that's just going to be du, right? Du, we have cosine x dx, right? So now what this becomes is the integral here of, so this whole top part is just du, and then here we have u squared plus 2u. All right. Okay. Now, looking at this table of integrals, that still doesn't get me to where I want, right? It's not one of these, right? At least maybe not yet. Right? It's not this either, u squared or a squared minus u squared. And it's not really this either here. Okay, so I need a different approach. Okay, so what I'm going to do here is a nice little trick when I do see something like this is I'm gonna complete the square. All right. Now the way I do that, by what I mean complete the square, is I want to factor this trinomial, right? So that when, essentially what I mean by that is, let's say that I want it to look like this, to be a perfect square, right? Because if I expand this out, this is a squared plus 2ab plus b squared. Okay? All right, so now the way I do that, all right, is I'm going to take a look at the coefficient in front of the u, and I'm going to divide it in half. All right, see, that way we divide by 2. So that gives me 1, and then I'm going to square it. So divide the coefficient of the linear term by 2, and whatever the result is, square that. Now, I can't just add in a factor, right? Remember, I have to balance it out, right? So if I add a 1 squared, I must also subtract the 1 squared. So there's no net change. Okay, and now I'm going to factor this, right? This is going to factor to u plus 1 squared. Right? And then minus 1 squared. Okay. All right. And now it looks more, now you can see how this kind of frees things up here. Now it looks like this form, right? Oops. U squared minus a squared, where for us, the u is just going to be replaced by u plus 1. So if I scroll down here, there's no root. Right? So we just have, where'd it go here? Here we go. 84b. Where we have my du over u squared minus a squared, where in this case, my u is just u plus 1, and then my a squared is just 1, right? 1 squared. So I'm going to use that to evaluate, right? So if I do that, then what's that? 1/2 ln of u plus 1 minus 1 over u plus 1 plus 1, and of course plus c. All right, now I'm going to simplify here, right? This is not quite what I want. ln plus 1 minus 1 is u plus 2 plus c, and then lastly, my integral was done in x, not u, so my substitution was sine. So sine x over sine x plus 2, and of course plus c. Okay, so as you can see, right, even though initially we're like, oh well, it's all we're doing is looking stuff up on a table. Sometimes it requires a little bit of work to kind of manipulate it so that we can look it up really easily.